everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable coefficients. So let's get going. Problem: solve x square into d square y by dx square plus 4x into dy by dx plus 2y equals to e power x. We are given a differential equation with variable coefficients, right? Now we are going to reduce the given differential equation to a differential equation with constant coefficients by making some substitution. Given differential equation, x square into d square y by dx square plus 4x into dy by dx plus 2y equal to e power x. We know that d is a differential operator with independent variable x. Then d square will be d square by dx square. Now we can write this equation as x square into d square y plus 4x dy plus 2y equal to e power x. Now take y common from all the three terms of LHS. We'll get x square d square plus 4xd plus 2 into y equal to e power x, which is a Cauchy's equation. Now put x equals to e power z, then log x equals to z for x greater than 0. Let theta equals to dy dz. Here theta is a differential operator whose independent variable is x. And xd equals to theta, x square d square equal to theta of theta minus 1. Now Cauchy's equation becomes, replace x square d square by theta of theta minus 1 plus 4 into replace xd by theta plus 2 into y equal to e, replace x by e power z. Okay, then theta into theta, theta square minus theta plus 4 theta plus 2 into y equal to e power z. Then theta square minus theta plus 4 theta is plus 3 theta plus 2 into y equal to e power z. So we have reduced the given differential equation to a differential equation with quotient equation. Sorry, constant coefficients, right? And also this in operator form f of theta into y equals to some function of z, right? Which is in operator form f of theta into y equals to some function of z, where f of theta equal to theta square plus 3 theta plus 2. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Now let's find yc and yp. The auxiliary equation is, we'll find yc using the auxiliary equation, and the auxiliary equation is f of m equals to 0, where f of m equal to, we have f of theta, theta square plus 3 theta plus 2. Let's replace differential operator theta by m, so that we'll get f of m equals to m square plus 3m plus 2. Then our auxiliary equation becomes m square plus 3m plus 2 equal to 0. Now split this 3m as 2m plus m. Now take m common from the first two terms. We'll get m times m plus 2, and the next two terms remains the same. If you notice, we are having m plus 2 in both the terms, so let's take m plus 2 common now. We'll get m plus 2 into m plus 1 equals to 0, right? M plus 2 into m plus 1 equals to 0. Now we equate each factor to 0. From m plus 2 equals to 0, we'll get m equals to minus 2, and from m plus 1 equals to 0, we'll get m equals to minus 1. Then m equal to minus 2 minus 1 are the roots of our auxiliary equation. Therefore, the roots are real and distinct. We know that when two roots are real and equal, real and distinct, say m1 and m2 are real and distinct, then yc will be c1 e power 1 root into x plus c2 e power another root into x. Now coming to our complementary function. Yc equal to c1 e power minus 2 into, here z is our independent variable, right? So instead of writing x, we'll write z. Plus c2 into e power minus 1 into z. This equals to c1 e power minus 2z plus c2 e power minus z. Now we are having yc in terms of z. We need to write in terms of x by replacing e power z by x, right? In order to replace e power z by x, we'll write e power minus 2z as e power z whole power minus 2 plus c2 into, we'll write e power minus z as e power z whole power minus 1, right? This equals to c1. Now replace e power z by x, we'll get x power minus 2 plus c2 x power minus 1. We know that x power minus n is 1 by x power n. Then we can write c power minus 1 minus 2 as 1 by x square plus c2 into, write x inverse as 1 by x. This equals to c1 by x square and c2 by x, right? c1 into 1 by x square is c1 by x square and c2 into 1 by x is c2 by x. So we got yc now. Therefore yc equals to c1 by x square plus c2 by x. Now we need to find yp. Particular integral. We can find particular integral using 1 by f of theta into q of z. We have f of theta and q of z, where f of theta is theta square plus 3 theta plus 2 and q of z is e power z. Okay. Now we are having theta square plus 3 theta plus 2 in the denominator, right? We can write it as sum product of factors. We already have roots, right? M equals to minus 2 and minus 1. From this, we'll get m plus 2 into m plus 1 equals to 0, right? From auxiliary equation, then we are having m plus 2 and m plus 1. So we can write m square plus 3m plus 2 equals to m plus 2 into m plus 1 directly. Okay, that means we can just replace theta m by theta and we can write theta square f of theta as product of theta plus 2 into theta plus 1 for our convenience. We'll get to know now. 1 by, I'm going to write f of theta as product of two factors. Theta plus 2 into theta plus 1 into e power z. So we are having a fraction 1 by theta plus 2 into theta plus 1, right? We'll resolve this into partial fractions. 1 by theta plus 2 into theta plus 1 equals to a by theta plus 2 plus b by theta plus 1. then 1 by theta plus 2 into theta plus 1 equals to a into theta plus 1 plus b into theta plus 2 by theta plus 2 into theta plus 1, then 1 equals to a into theta plus 1 plus b into theta plus 2. Now we need to find AB values, right? When theta plus 1 equals to 0, theta equals to minus 1. Now put theta equals to minus 1 in this equation 1, then 1 becomes 1 equals to a into minus 1 plus 1 plus b into minus 1 plus 2. Then 1 equals to, this becomes 0 because we are having minus 1 and plus 1, right? B into minus 1 plus 2 is 1. Then b equals to 1. We got the value of b. Now let's find the value of a. Now put theta plus 2 equals to 0. Then we'll get theta equals to minus 2, right? Now replace theta equals to minus 2 in equation 1. Then we'll get 1 becomes 1 equals to a into minus 2 plus 1 plus b into minus 2 plus 2. Minus 2 plus 2 is 0. Then b term becomes 0. Then we'll get 1 equals to minus 2 plus 1 is minus 1. Minus 1 into a is minus a. Then a equal to minus 1. Right? Now replace AB values in this equation. Then we'll get 1 by theta plus 2 into theta plus 1 equals to, replace value of a by minus 1, we'll get minus 1 by theta plus 2 plus replace value of b by 1, we'll get 1 by theta plus 1, right? Since 1 by theta plus 2 into theta plus 1 equals to minus 1 by theta plus 2 plus 1 by theta plus 1, we can replace this fraction by minus 1 by theta plus 2 plus 1 by theta plus 1, or 1 by theta plus 1 minus 1 by theta plus 2. Okay, let's replace the fraction by 1 by theta plus 1 minus 1 by theta plus 2. Then yp becomes 1 by theta plus 1 minus 1 by theta plus 2 into e power z, right, which is equals to 1 by theta plus 1 into e power z minus 1 by theta plus 2 into e power z. Now let's find each term separately. Okay, for my convenience, I'll name the first term as u and second term as v. Okay. Let 1 by theta plus 1 into e power z equals to u. Okay. Then e power z equals to theta plus 1 into u. We'll take theta plus 1 to RHS, then we'll get theta plus 1 into u. Then e power z equals to theta u plus 1 into u. We know that theta is a differential operator with independent variable z, right? Replace theta by d by dz. We'll get d by dz of u plus u. Derivative of u with respect to z is du by dz. Okay, du by dz plus u equals to e power ez. So we got du by dz plus u equals to e power ez, which is linear equation in u and z, which is linear in u. Now find P1 and Q1, where P1 equals to coefficient of u 1 and Q1 equals to RHS part e power ez. Now find integral P1 dz is equals to integral 1 into dz equals to integral dz equals to z. Now find integrating factor which is given by e power integral p1 dz. So we have the value of integral p1 dz which is z. So integrating factor is e power z. And we'll find the solution of this using formula dependent variable u into integrating factor equals to integral q1 into integrating factor into dz. Okay, then we'll get u into integrating factor is e power z equals to integral q1 e power z into integrating factor e power z into dz. Let e power z equals to t. Now differentiate on both sides with respect to z. We'll get derivative of e power z with respect to z is e power z equals to derivative of t with respect to z is dt by dz. Then we'll get e power z dz equals to dt. Then this becomes u into replace e power z in the integration. We'll get e power t into replace e power z dz by dt. Okay. Integral e power t dt is e power t. Now again replace t by e power z. Then we'll get u into e power z equals to e power. We'll just replace this t by e power z. Right? Then u equals to 1 by e power z into e power z. Again we can write 1 by e power z as e power minus z into e power z. Now replace this u here. Then we'll get therefore 1 by theta plus 1 into e power z equals to e power minus z into e power z. Right? Now we'll go for the second one. So the result obtained from the first term is e power minus z into e power z. Let 1 by theta plus 2 into e power z be v. Okay. Now take theta plus 2 to RHS. We'll get e power z equals to theta plus 2 into v. Then e power z equals to theta v plus 2v. Again replace theta by d by dz plus 2v is equals to dv by dz plus 2v. Right? Then we can write the above as dv by dz plus 2v equal to e power z, which is linear equation in v and z. Now find P2 and Q2. P2 is a coefficient of V, which is 2, and Q2 is e power z. Now find integral P2 dz is equals to integral 2 dz is equals to 2 integral dz equals to 2z. Now find integrating factor which is given by e power integral P2 dz which is equals to e power 2z. Right? And we can find the solution of this equation using v into dependent variable into integrating factor equals to integral q2 into integrating factor into dz is equals to, or this becomes v into e power 2z equals to integral q is e power z into e power 2z into dz. Okay? Fine. Now let e power z okay equals to some s. Now differentiate on both sides with respect to z. Then derivative of e power z with respect to z is e power z equals to derivative of s with respect to z is ds by dz. Then e power z dz equals to ds, right? Now we can replace e power z by s and e power z dz by ds. But here we are having e power 2z. So we'll split e power 2z as e power z into e power z. Okay, we'll get e power z into, we'll just split e power 2z as e power z into e power z. Now it will be easy to replace e power z by s and e power z dz by ds. Okay, we'll get v into e power 2z equals to integral e power, just replace e power z by s, we'll get e power s into, replace this e power z by s into e power t, sorry, e power z dz can be replaced by ds. Right? Now, we can write this as v e power 2z equals to integral s into e power s ds. We know that integral x e power x dx equals to e power x times x minus 1. Right? Now we can apply this formula for s. Then we'll get v into e power 2z equals to integral s e power s ds is e power s into s minus 1. Right? Now replace s. Replace s by e power z. Then we'll get e power z into e power z minus 1. Okay? This equals to e power z into e power z minus e power z. Then v equal to 1 by e power 2z into e power z into e power z minus e power z. We know that 1 by e power 2z can be written as e power minus 2z, right? We'll get e power minus 2z into e power z into e power z minus e power z. This equals to e power minus 2z into e power z into e power z minus e power minus 2z into e power z. This equals to e power minus 2z. See, e power minus 2z into e power 2z is, at the powers we'll get e power minus 2z plus z, which is equals to e power minus 2z plus, this is z, okay, minus 2z plus z is minus z. So from this we'll get e power minus z into e power z minus e power minus 2z into e power z. So we got v now. Now replace this v by this one, or the result obtained from second one is e power minus z into e power z minus e power minus 2z into e power z. Therefore, 1 by theta plus 2 into e power z equals to v, right? Replace v by e power minus z into e power z minus e power minus 2z into e power z. So this is the result obtained from the second term. Now coming to yp. Yp becomes, result obtained from the first term is e power minus z into e power z minus of, result obtained from the second term is e power minus z into e power z minus e power minus 2z into e power z. Then yp becomes e power minus z into e power z minus e power minus z into e power z minus into minus plus e power minus 2z into e power z. Okay. C plus e power minus z e power z and minus e power minus z e power z gets cancelled, and yp equals to e power minus 2z into e power z. Now we are having yp in terms of z. We need to write in terms of x by replacing e power z by x and z by log x, right? So here we don't have separate z. So let's replace e power z by x. In order to replace e power z by x, we need to write e power minus 2z as e power z whole power minus 2 into e power z. Now replace e power z by z, x. Yp becomes x power minus 2 into e power x. And we know that x power minus n can be written as 1 by x power n. Then we can write x power minus 2 as 1 by x square into e power x, which is equals to e power x by x square. Therefore, yp equal to e power x by x square. So we got yp and yc. Let's now write the general solution of the given differential equation. The general solution is given by y equal to yc plus yp. Then y equals to yc, we have c1 by x square plus c2 by x, and yp is e power x by x square. So this is the required solution. So we have seen a problem from higher order linear differential equation with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.